Welcome back to the aircraft structure repair session. With me I have a piece of aircraft skin lap splice with a stringer, and you can see here skin. It's an aircraft skin end up here, and then another skin come up and end up here. So this is a splice. So this is a splice skin, one skin, second skin, splice here, lap together, splice, and there is 3 rows of rivets to join these two splice, and behind the splice it is strengthened by a stringer. It's a U channel stringer. So this is typical aircraft structure skin, splice, lap splice, lap because it goes over the other, and again this is first skin, start here, end up down here, and another skin start here and all the way, and 3 rivets, and we have stringer. And this skin simulated there was a damage. You can see a cut here, from here all the way here to here. So consider it's a cut. It was damaged somewhere before. It's a cut, and the stringer is not damaged. So the damage was cut off, and then a doubler was installed. A doubler was installed over the damage which was cut off. You can see 3 rivets rows around the cut. So the cut, the stiffness is not damaged. So it was a skin before, there's no filler installed here. So we have a good shim inside here. Behind here is a shim to prevent any stresses on the stringer when you rivet to the skin. So you have to protect it by putting a shim. The shim will be the same thickness to the original skin. Okay, for the cut, when you have a damage like this for a cut, first thing you need to know is a load. What will be the load that you use to design this? So the load will be, for this kind of structure, normally this is circumferential, this is a curvature up here, and this is longitudinal. So the load will be, for the circumferential, there's a pressure. Aircraft structure is pressurized, so the pressure will be against this skin, and obviously longitudinal will be a axial load, tension and compression depending on the direction. So for the cut, you have to consider to design the structure. For you to determine the load, you need to consider, because we have load in this direction. When you pressurize, so the skin will be under tension, and then you have also axial loading, tension, compression. You bend the aircraft fuselage, you got tension, you got compression. So you also have a axial load here. So we have axial load here, tension, and we also have axial load here, tension and compression. And because of the pressure, so the load is this is skin, thin skin. There's no true thickness load, so the load will be transferred, become a shear. So for the cut, you have a shear load around the cut. So for this load combination, we have both shear and tension. So we have tension. So this area here is loaded, this area is loaded, this area is loaded, this area is loaded. So the load that we determine is to determine the number of fastener required to carry the load. For the load analysis, you consider this area we have tension. Okay, the cut here we have tension, we have shear, and here we have tension, we have shear. Similarly, in the different direction, we also have tension and shear, tension and shear. So here we have combination of shear along the cut, and we have a tension perpendicular to the cut. So the load, total load here is a resultant of shear and tension. So later I will explain to you the analysis to determine the load. So here is just a physical representation of lap splice repair with the doubler, and how we want to start designing the repair by determining the load. So from this piece of sample, you will be able to see how the structure is loaded due to the pressurized of the fuselage, due to the longitudinal bending in torsion of the fuselage structure, which translated into the cut as shear along the cut and also tension, okay, perpendicular to the cut. So this is how this kind of structure repair design looking at the load. That is the beginning of the process in repairing the aircraft structure by looking at the load. From the load, we are sizing the rivets. You can see the rivets here, 3 rows, and how we come up with the 3 rows for rivet. Okay, thank you.